Hi, I'm Matt, and in this video we are going to go over how to do math with significant figures, particularly how we round our answers based on the type of problem it is. So, before we get into significant figures, I would like to review the place value chart you all probably remember from when you were younger. So we have our decimal in the middle, and then going to the left we have our ones place, our hundreds place, and our thousands place. And going to the right, it's flipped. We have our tenths, then our hundredths, then our thousandths, and so on. This will be very important when we get to adding and subtracting with significant figures. Now with that out of the way, what are the rules for addition and subtraction? So when we add or subtract our numbers, our answer can only be as precise as our least precise value. And a number is precise to the place where its rightmost significant figure is. So in 103.9, it is precise to the tenths place, since that 9 is significant and it's the most right significant figure. In 130, it is precise to the tens place for the same reason. Now, if we were to add these, we would have to round to the tens place, because 130 is our less precise number. So here are the steps that we are going to use when we add or subtract numbers with significant figures. So we're first going to determine what place each value is precise to. Then we are going to determine which of these numbers is the least precise and note the place of its rightmost significant figure. Then we are going to just throw the numbers in a calculator and add them together or subtract them. And then we're going to round to that place we identified in part 2. So with that, let's try some practice. Now, here we have 23.3 plus 7.48. So now, let's identify what each number is precise to. 23.3's rightmost significant figure is the 3, and is therefore precise to the tenths place, while 7.48 is precise to the hundredths place. So now, which is least precise? When a number is least precise, generally speaking, it will have less decimal places, such as the 23.3. So 23.3 is least precise, so we're going to round to the tenths place, because that's where its rightmost significant figure is. Then, we're going to throw these numbers into a calculator and add them together. That gives us 30.78. And the last step is to just round like we would in math class to the tenths place. So, if we round, the 8 tells the 7 to go up, and we will get 30.8. Now, let's try a subtraction question. So we have 13.459 minus 2. So, where is each of these numbers precise to? 13.459 has 3 digits after the decimal place, and is therefore precise to the thousandths place. While 2, it has no decimals and is only precise to the ones place. Here, 2 is least precise, so we're going to round to the ones place. It is least precise because it has no decimals, unlike 13.459. When we plug this into a calculator, we get 11.459. And our last step is to round to the ones place. That 4 tells the 1 to stay the same, so our final answer would be 11. Lastly, let's try this one. We have 12.9 plus 4.81 minus 0.833. The rules do not change when we have 3 different numbers. We're just going to do step 1 anyway and determine where each of these numbers is precise to. So 12.9 is precise to the tenths place, 4.81 is precise to the hundredths place, and 0.833 is precise to a thousandths place. So here, which one of these would be least precise? That would be 12.9, because it has the least amount of decimals, or its rightmost significant figure is farthest to the left on the place value chart. So in this question, we're going to round to the tenths. Next, we're going to just plug this into a calculator and get 16.877. And our last step is to round to the tenths place. the 7 tells the 8 to go up, and we get 16.9. Now, we are going to move on to the rules for multiplication and division. These are vastly different from those of addition and subtraction. So when we multiply and divide, the answer can only have as many sig figs as the number with the least amount of sig figs, and normal sig fig rules apply to determine this. So here are the steps to these problems. We determine the amount of sig figs in each number, and then we determine which one has the fewest and note how many sig figs that is. Then we're actually going to do the math, most likely in a calculator, and then we're going to round to the amount of significant figures we determined in step 2. So now let's try some practice with this. So first, we have 63.9 times 1.5. So 63.9 will have 3 significant figures, and 1.5 has 2 significant figures. So 1.5 has the least amount of sig figs, so our answer will have 2 significant figures. Then step 3 is to do the actual math, which gives us 95.85. And to round this to 2 sig figs, we're only going to be able to have a number in the tens and the ones place. So that 8 will tell the 5 to go up, which gives us 96, which is indeed 2 significant figures. Now, let's try 7.98 divided by 2.111. So 7.98 will have 3 significant figures, while 2.111 has 4 significant figures. So 7.98 has the least amount of significant figures, so our answer will have 3 sig figs, because that's as many as 7.98 has. And when we do this math in the calculator, we are going to get 3.7800 and so on. But we only want 3 significant figures in our answer, so we're only going to use the 3, 7, and 8. And that 0 tells the 8 to stay the same, so our answer will be 3.78. For our last example, let's try 0.55 times 3.987 times 134. So the steps don't change even though we have 3 numbers. First, 0.55 has 2 significant figures, 3.987 has 4 significant figures, and 134 has 3 significant figures. So of the 3, which one has the least amount of sig figs? That will be 0.55 because it only has 2. Using that, we know our answer can only have 2 significant figures. Plugging that long equation into our calculator gives us 293.8419. And now we need to round this to only 2 significant figures. So we are actually only going to keep the number in the hundreds, which is the 2, and the number in the tens, which is the 9. And we're going to round everything else away. And that 3 tells the 9 to stay the same, so rounded to sig figs, this is 290. Now that we've gone over all the rules, here are 6 questions you could use to practice. The first 3 are a mix of addition and subtraction, and the last 3 are a mix of multiplication and division. Please solve these out and then round to the correct number of significant figures. The answers will be provided for you on the next slide. The solutions are as follows. The left column is what we get when we plug it into a calculator, and the right column is after we round to the correct number of sig figs. So for question 1, we had to round to the ones, which gave us 255. For question 2, we had to round to the thousandths, which gave us 123.986. For question 3, we had to round to the ones, which gave us 141. For question 4, we had to round to 1 significant figure, so we got 0.9. For question 5, we had to round to 2 significant figures, so that gives us 480. And for question 6, we had to round to 2 significant figures, which gave us 460. Hopefully you got these. If not, feel free to leave a question in the comments below and I will get back to you as quickly as possible. Thank you so much for watching. Have a great day.